So we're over here on the second RosenBridge workshop with the first cohort of SPOs. We have MHS Sam with us. Joe is going to join as well from the EF. And
I'm here.
We have quite a few SPOs with us. This call is recorded and will be posted on YouTube, so everybody can go and take a look at it later on. So I just wanted to start with you know, a big question that I wanted to ask everybody. I kind of made a poll on Twitter as well. Wanted to get everybody's opinion. We would like to open these workshops to all the SPOs, since the proposal got funded from the community, and we're very thankful for that, for all the support that everybody showed. So I think it's more than fair for us to just put that question out there to the first cohort of SPOs. If you guys would like us to open this up to at least all the SPOs of the community, and later on, when things are you know, way down the road, we can even discuss about opening it up for everybody. With that being said, again, I will leave this up to here. You guys DM me. It doesn't have to be public and whatnot. You know, I respect everybody's privacy. Feel free to DM me or send me an email with a yes or a no and your reason if you would like to put some more time to that. And without further ado, I will give the mic to MHS Sam. He's going to give us an amazing presentation today. I'm really looking forward to this. I will sit back and leave the big guys in the room talk. Sam, the mic to you.
Thank you, Jeff. Let me stop my video and share my screen. Oh, since the screen sharing is disabled, can you enable it?
I don't think we can see anything. Can you guys see Sam's screen?
You might need to make him the host, Chef.
Oh, really?
Yeah, that would give him screen sharing power.
Nice to see you, Joe.
You too. Morning, everybody.
Morning, Joe.
Good morning.
Okay, I got this.
Hey, everybody.
Hey, Sam, you can check now. I think I gave you...
Yeah, I'm seeing something. Okay, I have to quit and reopen the Zoom, so it may take 1 or 2 minutes. Sorry.
Okay, sounds good. Joe, is there anything you would like to share with us?
No, I would just say from my side, a larger set of actors equals better assumptions. So I would love to see this more open. I know that part of having it as like a smaller group initially was to just have, I guess, more of a focus group feedback oriented thing as we spin up some of this infrastructure, people start testing it, we get some ideas for improvement. But long term, it's open source, right? So if we can get educational material out there, you know, for SPOs and anyone else that wants to participate, it just helps with the distribution of the bridge, which ultimately is a good thing.
All right, we got Sam. Sam is back.
Yeah. I can share now.
Last time I used Zoom, Theodore, I had to make the presenter the host.
I made him a host right now. I just did, actually. Thank God it's working.
Yeah. Can you see my screen?
Yes, I can see it.
It's coming through on my end.
Yep, looks good for me too.
Have fun, guys. Enjoy.
Okay. Thank you guys for your time. I will be here with you today for the second workshop of RosenBridge. Today we are going to an overview of how Rosen works and the role of watchers in the Rosen. So today talks is about basically how bridges fail, and based on that, what is Rosen's design principles and actually how it works. Later we'll talk about the role of watchers in Rosen and why they are important, and how to become a watcher actually, and at the end we'll showcase the watcher apps. Okay, let me start with two nice quotes, which was actually inspiring to me building Rosen. First one is about actually a reason why hackers have targeted these cross-chain bridges of late is because of the immense technical sophistication involved in creating these kind of services. So we should keep in mind that if you want to build a bridge, it should be as simple as possible, but not more simpler than necessary actually. And another one is if you are trying to create a bridge between n different cryptocurrencies, the complexity of that is n squared. And this one is one of the most inspiring codes while building Rosen, and we actually tried to build design and build a bridge that its complexity doesn't increase by actually in n square while adding new chains. So you will see that later in the design of Rosen. Okay, so let me give a quick start of why do bridges fail. First of all, it's because their structure is rather complicated, because lots of smart contracts or there are lots of different consideration about verification, and having a leg in different networks may cause many different unseen bugs and smart contract failures. Another important one is they are actually tempting targets because large sums of funds are stored in them without actually robust protection. The hackers gain an incentive is very huge. So one of the aspects of Rosen, which we are not going through it today, is having funds secured in cold storage. But it's out of concept of this presentation. Another major reason of failures is false deposit and actually false verification. That means tricking the protocol into thinking attackers had deposited money when they actually had not. Another reason is validator flaws, likely flaws in deposit validation before permitting transfer, like what happened in Warhol. And another one is validator takeovers, actually taking over certain number of validators, like what happened in Ronin network. And the attack vectors that are open to breach are smart contracts, faulty verification, proof or signature fabrication, forks and reorgs, bugs in cryptographic libraries and implementation, network attacks, secret exposure, DOSes, and other kind of traditional attacks. And a lot of big security assumptions or a small guardian sets. Actually, the bridges that seems to be decentralized, but all nodes are running on a single computer. So in Rosen's design, we had actually some principles to mitigate these attack vectors, and from what we learned from previous attacks, we tried to design something that can somehow mitigate these attacks and vulnerabilities. So first principle is to keep it simple. As you can see in Rosen, you can see in next slide in Rosen. Rosen is actually created and designed based on a series of off-chain verifications. So there is no smart contract verification of events involved. And so a series of off-chain verification and on-chain actions. And it's, as you may know, it's the main principle in every UTXO blockchain. So Rosen is actually based on that idea and is utilizing that idea. In verification, we are doing off-chain verification instead of a smart contract-based verification. The verifications are individual and independent. And one of the reasons that watchers verification is very important in Rosen is that our verification is individual and independent, and watchers verification is very important here. It can be multi-channel, so each watcher or each guard can use a different channel to verify the transaction. It's based on majority consensus. It's actually delayed, so Rosen is not a fast bridge, and it's actually slow by design, and the verification is recurring. So in different steps, we have a recurring verification. We try to make it decentralized, so we have a decentralized layer of watchers, which is open to everyone. And we have a federated set of guards, which is medium-sized and permission. We only used smart contracts on Ergo side, and you can see later that these smart contracts are only for reward distribution and incentivizing the good behavior on the bridge, not for event verification, actually. We somehow achieved the linear expansion complexity because it's ergo-centric, and we didn't use smart contracts on other chains. So adding a new chain to this bridge will not result in more complexity, more than linear complexity, actually. It is completely stateless, so both watchers and guards can go on and off eventually without losing anything. And they act without storing any meaningful state. We have cold storage, so we have minimized the incentive and gains of hackers. Both watchers and guards have skin in the game, so the bridge works with rewards and penalties for good and bad behavior. It's very low cost because it's ergo-centric, and fees on Ergo are very low, and we are trying to keep everything open, and our codes are open source and can be viewed by the public. Okay, let's have a quick jump on how verification is done on other bridges and why Rosen is different in this regard. If we want to categorize different type of verification, we can point to three major different type of verification. which I'm going quickly through them. First of them is a smart contract-based verification on a destination chain to verify a proof of block that is actually happened on the origin chain. So you somehow have to represent the state of the origin chain on the target chain in order to enable some smart contracts to be able to verify what happened in the origin chain. In most cases, this state is provided by decentralized relays, and in practice, this method has been compromised several times in the past years. One major issue of this method is that verifying a proof is only being done once. So it's really prone to forks, proof fabrication, smart contract bugs, and other kind of attacks. And we really try to avoid this kind of verification. Another kind of verification is indirect verification. So there are some guards in both chains, and some guards in the origin chain will create a proof about what happened on that chain. And the guards on the destination chain will not verify the event itself, but will verify the proof that is made by the origin network's guards. And it's somehow what's happening in Gravity and Wormhole, and what happened in the Solana hack last year. Another kind of verification is called optimistic, which there are some oracles involved, and a few of these oracles will report some events on the target chain, but these reports will be valid after a time window. Actually, if no other oracle is reporting a fraudulent activity. It is what actually used in Nomad and has been hacked last year. So Rosen's approach is completely different. We are using direct verification and off-chain verification of events. In Rosen, we are having reporting and settlement networks completely separated. The reporting network is what we call the watcher network or watcher set, and the settlement network is or settlement layer is the guard set. So we have a decentralized reporting layer, which are the watchers, and they are working as a cross-chain oracle. We have a federated settlement layer known as guards. This bridge is incentivized. In order to have it decentralized, we have to make it profitable for good activity of entities. There is multiple steps of verification, and verification is direct and off-chain, so it's not based on the smart contracts. The smart contracts are only used on Ergo side and are mostly used for managing the rewards and the incentivization, not for the event verification. Rosen setup is rather simple. We have one guard set, which are a set of well-known entities. We aim to reach up to 3 guards in the future. These guards have to put a reasonable amount of collateral, and they have a multi-sig wallet and some contracts on Ergo side, and they will have a multi-sig wallet on Cardano side and any other future chains that is going to be integrated in Rosen. On the other hand, we have one watcher set for every chain. So keep it in mind, we have one watcher set in every chain. So here we have Ergo watchers and Cardano watchers, and they are two different sets. And each watcher set actually are watching their network as an origin network. These watchers act completely independently, and each watcher actually has a limit on how many reports he can have. And these permits and this allowance actually are given by locking RSN tokens, and watchers will be rewarded for their successful reports. So simply, there are some cross-chain oracles which are monitoring their network as an origin network, and based on their reports from what happened in their origin network, they will be rewarded on Ergo network. And there are a few wallets involved. So we have a multi-sig wallet on Ergo, we have a multi-sig on Cardano, and we have several multi-sig as cold wallets on each network. So here is a overall presentation of what is happening and simplified version of what is happening on Rosen. As you can see, watchers are observing and reporting. We will go through these reports and these events in details. So watchers are observing and reporting. These reports are being aggregated, and based on these aggregated reports, the guards will start their work. So the guards are inactive until they receive an aggregated event. So the guards actually are not actively monitoring any network, and it will decrease their complexity to a certain degree. This part is regarding the guards operation, which I'm trying to escape today. So simply guard verify actually that event independently again. So each guard verifies that aggregated report by going through a simple verification on the origin network. And if a majority of guards are actually have consensus over that event, they will start the payment transaction. And when the transfer is done and the payment is actually done, the reward will be distributed to the guard set and the watcher set. So in short, and in a simplified view, the watcher's process is as follows. Let me consider a Cardano watcher. This watcher will monitor the bridge locked address on Cardano. And in case of an input transaction, he waits for some confirmations and will check the validity of that input transaction. In case of invalid transaction, say maybe it's invalid because the metadata is not right, maybe the fee is not enough, or other technical limitations, or maybe it's the network is forked and this transaction is not on the network anymore. So after some confirmations, or passing some time, actually, the watcher will ignore an invalid transaction and will not report it. But in case of a valid transaction, the watcher will report it on Ergo side. by creating a transaction, actually creating an ergo box. We are calling the UTXO outputs as boxes in ergo. So I'm using the word box often. Okay. So each watcher actually is doing this monitoring and reporting independently. And after enough reports are available on Ergo, one of the watchers can create a triggered actually event report, which is an aggregated event in which the metadata and the data of that event, that input is present. And the guards will look and monitor for this kind of boxes on Ergo. So the guards are not monitoring, for example, in this case, the Cardano chain. They are looking for new triggered events. And finally, the guards process will be started, and after successful settlement, the watchers will be rewarded. So it's the simple process, as you can see, but there are clearly more complications involved to ensure the good behavior and good reports. So we have two terms here for watchers. One is the collateral and the other is reporting permits. In order to be a watcher, one should actually lock a one-time collateral. And this collateral is to mitigate the cyber attack, because we are trying to make it financially inefficient to run several watchers. It's still possible for anyone to run several watchers, but if we don't have this, it's actually a barrier of entry in order to prevent attackers from running a lot of watchers without any cost and attacking the system by creating a lot of malicious reports. So, for example, say there is a need for 1,000 ERG and about $1,000 in RSN token, because we don't know the price of RSN yet. So it would be something, as an example, about $1,000 to $2,000 as a starter. So you need to put this collateral to activate your watcher and actually getting a watcher ID token. This collateral is fully refundable, and there is no risk of seizure or any kind of loss on this collateral. It's completely just a simple barrier of entry. After putting the collateral, watchers need some permits in order to be able to report events. So it's a refundable cost of reporting. And I will show in the next slide what is the life cycle of these permit tokens and why they're completely refundable. So, for example, say you need 10,000 permit tokens for one reporting permit. There might be a confusion here, but I will make it clear at the end. So watchers actually need to lock some RSN in order to receive these permit tokens. And these permit tokens are at risk of seizure in case of malicious behavior. And watcher may need several reporting permits in order to report several concurrent events, because Rosen is slow, and having one allowance is not enough for reporting several events. So in one case, you have to wait for your permits to be refunded, and you can use them again, or you can have several reporting permits in order to report several concurrent unsettled events on your chain. Okay. So you will receive one permit token per RSN, and it's an static ratio. So we have, if you lock one RSN, you will receive one permit token in your Watcher's wallet. But you may need, for example, 10K of them for one reporting permit. So, and it's a dynamic ratio, and we are trying to calibrate this ratio over time to manage the number of reports in the okay. Now that you know what is collateral and what is the reporting permit, let's go into a more detailed view of what's actually the Watcher's process. Okay, again, assume that you are a Cardano watcher who have put the collateral and have some reporting permits. Your watcher is monitoring the lock wallet on Cardano, and in case of a valid input, the watcher creates a commitment on Ergo. On the previous slide, I said you will report that event, and these reports will be aggregated, but in order to avoid copy pasting the reports on Ergo, we are utilizing a simple commit and reveal mechanism here. So you are creating a commitment, an event commitment on Ergo. And when there is enough commitment, and this can be verified off-chain by your watcher app, one of the watchers, any one of them, can reveal his commitment by spending all these commitments. So it cleans the network from these commitment boxes, and will create a new box, which we are calling event trigger box on Ergo. And this event trigger box contains the event data, and the guard set are monitoring event Ergo for these tokens. So as you can see, it's a multiple step verification and action. It's monitoring of chain. So you are not utilizing any smart contract. You are simply monitoring Cardano using Node Explorer, etc. For new events. Then you commit what you have seen and what you want to report on Ergo. It's an on-chain action. So you are monitoring Ergo to see if other watchers are reporting the same event. If you have the data, you can actually do this comparison. But if you don't have this data and you are not monitoring Cardano, you can't copy and create a new commit. So it's a comparison. It's doing off-chain, and later there will be a reveal and a trigger, which is an on-chain action. And after that, the guards process will be started, and there will be two cases. In case of a malicious, malicious event trigger box, all of the involved watchers will be penalized by slashing their permits that they have put in their boxes. And in case of a successful settlement, all permit tokens will be refunded, so they can be used again for other reports, and all involved watchers will be rewarded by the guards. and you can see that you will see that rewards are RSN tokens actually. Okay, so this is the report permits life cycle. If you are not involved in malicious activities and malicious reports, you will never get your permits seized. And you observe the report will be triggered, and in case of a valid report, your permits will be refunded back to you. So simply they can acquired by locking RSN. They will be used in the contracts, but they are not consumed in reporting. So you are using them as some collateral for being honest in reporting. And in case of creating a malicious actual trigger, all involved vouchers will be slashed. And in other cases, these tokens will be refunded to your wallet and can be used again. So is it a complicated task? So you should know all of these stuff in order to be a voucher? Actually not. Actually, we are trying to make it as simple as possible, and I can say that anyone can be a voucher, but by just running the voucher app and doing a few steps in the app, and these steps are actually configuring your voucher. And it's more about configuring your data sources, putting some collateral, receiving some reporting permits, and monitoring the network. And as you can see later in the app itself, all of these tasks are handled in the app itself. Okay. Okay, so another question might be, what is the hardware requirement for being a watcher? So we have a variety of different requirements based on what you want to do. The minimum requirement of running the watcher service or the watcher application itself is 1 core CPU, 1 GB of RAM, and about 20 GB of storage, but really common to have at least 2 core CPU, 2 GB of RAM, and 20 GB of storage. And this might vary a lot based on what you are trying to do with your data source. So simply you can use public nodes as your data sources. So you can use the public Ergo node as long as actually these nodes are public. The required APIs on them are public. Currently they are. And you can use Koyos, for example, on Cardano. But if you want, you can run an Ergo node, which is pretty light for yourself. So you need more hardware requirements in this case, and you can run an Ogmios client on your hardware infrastructure, which will require 2 more cores and about 35 GB of RAM, which is rather high. Okay, so we actually wanted to keep it lightweight. So as you can see, you can use public nodes, and the other option is using Ergo node and Ogmios, which they are again somehow lightweight. But as you are SPOs, you already have the Cardano node, which is the heavy part of and we currently don't have the Cardano node support because we were thinking about making it lightweight. But as you have the Cardano node already, we will add the support for the Cardano node. So you already have the Cardano node. You will have an Ergo node, which is very light and with only one, maybe two more cores and two more gigabytes of RAM and 20 more gigabytes of storage. You will have a completely self-hosted watcher without relying on any actually outside source. On the app itself, we are currently have the Docker image available, and I will publish the installation document probably by tomorrow or the day after, and the executables will be available in 2 or 3 weeks if you want to run them on Windows, Mac OS, or on Linux. We are also trying to optimize it for running on Raspberry Pis and similar devices, but what we already have and you can use right away is the Docker image. Okay, so let's dive into some small details which I have said in previous slides, but I want to emphasize on those and make them more clear actually. So each chain operates actually with its independent set of watchers. So currently, as we have Ergo and Cardano, we have 2 sets of watchers, and one of them is Ergo watchers, and the other one is Cardano watchers. And the configuration, collateral, permits, prices, and other stuff may vary between different watcher sets. These configurations may include a few factors. For example, percentage of watchers required to report an event for trigger guards. So say if we have a lot of watchers, how many of them is required, at least is required to trigger an event. Another parameter is how many watchers enough for triggering a guard. So in case that we have a lot of watchers, we should not wait for a lot of them to report, and a threshold of them will be enough. And it will accelerate the reporting process. How many permit tokens are required for each specific chain? The mandatory collateral on each chain may vary. So based on different parameters, we may decide to differentiate between the collateral requirement on different network. Currently, we have Cardano and Ergo, but in future we may have EVM chains. So it's a parameter that we can manage. For example, in order to incentivize the new watchers to join a specific network or smaller networks in the future. And the reward share also may vary in a different chain. So guards may decide to make it different between different sets of watchers on different networks. Okay, so what is the rewards that the watcher will be given? A portion of the bridging fee is being rewarded to watchers. So watchers are reporting as Oracle, and after a successful settlement, the breach fee will be divided between the guard set itself and the involved watchers. And involved watchers means actually two things. The watchers on the origin network. So if the transfer is from Cardano to Ergo, the Cardano watchers are reporting that event, and Ergo watchers have nothing to do with it. So the Cardano watchers will be rewarded. And I mean involved watchers, and that means you may not report, decide to not report an event, and you are not involved on that report, so you will not be rewarded for that specific event. And in Rosen for each token, the breach fee and the network fee are being deducted from the token itself, but the rewards will be paid in RSN. So for each supported token, we will have a map of that indicates its conversion ratio to RSN, and this conversion ratio is dynamic, but not volatile somehow. So it will be updated periodically, say every 2 weeks or every 1 month, for example. So at some point, you might get rewarded more than your actual reward, your deserved reward, and in some points of time, you may rewarded less because the volatility of that transferred asset regarding RSN's price. Okay, that was the overview, and I have a few questions and answers, which might be your question, I guess. So I will quickly go over them. So can you have run multiple watchers? Yes, absolutely. You can run multiple watchers for a single network or for multiple networks. So you are not limited to run only one watcher, or you are not restricted to be a Cardano watcher, for example. You can run as many watchers as you want, as long as you put the collateral for each of them, and you can get the importance of why we need the collateral here. So as long as you put separate collateral for them and stake some RSN in order to receive reporting permits for them, you can run as multiple watchers as you want. Okay, does my reward decrease if there are many watchers in my network? Yes. The total reward is distributed equally to all reporting watchers, all involved watchers, and the more watchers reporting an event, your share will diminish. Some recalibrations will be made, and some recalibrations are possible. So that's actually why we may change the permit price or collateral price, for example. And it's somehow kind of proof of work mining. Currently, we have only the 2 chains, but in the future, we have several chains. So if the number of watchers in one specific network is getting higher than necessary, the reward will start to diminish. But it's not actually the end of history, so you can simply try a different network and be a watcher to a different network. for a short period of time or a long period of time, and earn rewards from those networks. So it's somehow kind of work that miners are doing, switching from chain to chain when their reward is decreasing or increasing. Okay, consider that you have sent a wrong commitment, or you have sent a report, but you want to undo it or alter it. You can redo your work, and you can actually, as long as the trigger is not created, you can change your commitment and change your report. Okay. Okay, another question that I've missed and I didn't write it here is that what if you report wrong actually event, but it is not triggered? Usually a wrong report should not be triggered because other watchers are not agreeing with you. But in case that a lot of watchers are doing malicious work, they can trigger a fraudulent event. So we will penalize watchers in case of creating a fraudulent trigger event, not in case of fraudulent or wrong events. So if a watcher makes a wrong report, in 99% of percentages of situations, it will not be triggered because it's wrong, and other watchers are not agree with that watcher. So after some time is passed, we have a cleanup service that will clean the network from those unspent commitments, and the permits will be sent back to the watcher, and he will not lose anything. But in case of collusion actually between a few watchers in order to create a fraudulent event trigger, the slashing will kick. And one of the cases of a fraudulent event is when a trigger event is reported twice. So consider some situation that a set of watchers is trying to make guards believe that the second report is a new actually report. Simply the watcher app is preventing this kind of reports, and if something like this is happening, it means that a set of watchers have altered their code in order to enable this kind of fraudulent activity, and the guards will detect actually this kind of fraudulent reports, and the second report will be penalized. Okay, so that was my presentation, and I want to showcase the so-called watcher app here. Okay. Okay, so I have the watcher app running on a server, and I'm accessing its UI from my computer, and some stuff here may look weird, like for example this token ID. because we are using test tokens. It's live on the mainnet, but using test tokens. So some names and IDs are doesn't have the necessary map actually. So you can see your dashboard here. It's a watcher for Ergo Network. If you are a Cardano watcher, you may see the Cardano logo here. This second box will show how many reports you can make, and this shows how many is still available. So in this case, this watcher can report 1,000 events, but he already reported a few of them. So until they are settled, he cannot use those permits. You can see how many ergs you have, you can see how many RSNs you have, and you can see the state of your watcher here, your tokens, and your revenue will be shown here. And this is your watcher's address, so you can top it up with required ergs and RSN. Let me go through different sections. In the health sections, we are monitoring the app itself will monitor different states. For example, if the watcher has enough reporting permits, if there are logs, errors or warnings in the logs, if it has enough errors for paying fees, if it has the watcher ID token, and the status of Cardano node synchronization and its connection, and Ergo node synchronization, and it's inside the scanner, the health status of that. You can see your observations here. So this table will show all the events that you have observed and committed to them. And this events tab, you will see all the triggered events, whether either you are involved in them or not. So observations are your observations and reports, and events is what is currently happening, and the consensus of watchers. So in these events, in one of those events, you may be involved, and you have been reporting that event, and you are in the agreement, or you may not. Anyway, it will be shown here. In the last section, you will see your revenues by reporting, so you can see in which report how much RSN and ERG you have earned. Let me get back to the first section. Okay, we will have two action buttons here, one for pausing and another for stopping the watcher app without stopping or killing the watcher daemon, but it will be not active in the very first releases, and later we will enable them. Not a big deal, but they will be inactive in the first releases. Let me start with the withdraw. You can so your watcher actually is a wallet too, but we recommend that you only use it for the purpose of watching only, and not to use it as a regular wallet to send and receive funds, because we need to check that you have this WID token. This is your NFT that indicates you are a watcher. But on Ergo, if you are trying to send some transaction, the change box may include this token, and for some amount of time, you cannot work regularly as a watcher. So in order to mitigate your use cases, your simple use cases that you want from a wallet, we have put the withdraw section here, so you can select each of your tokens. For example, you can withdraw your rewards, your RSN tokens. The name of RSN is pretty secret here. Sorry, it's a test RSN. So you can withdraw your rewards, for example. You can withdraw your ergs, and it will be done individually. And on the back end, we will handle to not move the WID token accidentally. Okay, so we have two actions here, lock and unlock, and these two actions are for putting collateral and redeeming collateral and purchasing permit tokens. And we have integrated these two actions into one. So when you want to buy your first permit, you need to put the collateral. So your first permit, your first request actually to put the permit will deduct the required collateral from your wallet, and will put the collateral, and will give you actually the very first permit. And after that, the transaction builder will know that you have this collateral, and will do another task, which is locking RSN for receiving permit tokens. So it's just a single click here. And on the unlock section, we have the same thing. So you can unlock your permit tokens. So you can unlock your permit tokens and unstake your locked RSNs that you have put for receiving those permits. And when you want to redeem the last permit that you have, it will automatically trigger the collateral unlock, and it will be sent back to you. As you can see, you have an Ergo wallet here, an Ergo address here that you can top it up with ERG and RSN in order to pay for mining fees on Ergo, which are pretty tiny, and for top it up for acquiring collateral and staking RSN in order to receive permits. Okay, I think we're good. Okay, Jeff, let's get back to you. If there is any question, I would be happy to answer. And sorry if it takes about 40 minutes. Sorry for that.
No, don't be sorry. You nailed it.
Oh, okay. It's more than 1 hour. Okay.
I was actually I learned so much out of your presentation, so I couldn't thank you enough for this. I know there's quite a few questions, and actually the people that participated on this call posted their questions on Discord. So I'll make sure I'll put them together, and that way we can give answers to them, and you know, add that into the FAQ that you already have. That way, you know, we have more information public for everybody. But no, I think it was great, man. I'm not sure if anybody here would like to add anything. Joe, if there's anything you would like to add, we will have another call in, I don't know, 12 hours or so. We will do this once again, but I will have this recording posted on YouTube, and we'll send out emails, and we'll have everything public as well. So thank you so much, guys, for joining us. I know we ran a few minutes late. We did better than the first call. Sam, we really appreciate all the knowledge that you shared with us, and we'll make sure we'll put everything public as soon as, most likely as of tomorrow. Everything will be uploaded and public for everybody to go and check out. Joe, is there anything you would like to add before we conclude this call?
No, I would just encourage everyone that has questions, comments, concerns to drop them on the Discord, and we'll try to work our way through. That way everybody has a clearer picture of everything we covered. Hopefully this video drops live in a day or two, and it grows from that point. Thanks everybody for your time.
Hopefully there is sound on this video this time. All right, guys, thank you so much for joining us. Take care.
Thank you for
Thank you so much. Thank you, Sam. That was a great presentation.